Get ready to enter a brave new world with your host, Vasant Dar.
Brave New World is supported by the Center for Data Science, or CDS, at NYU. If your organization is interested in engaging with CDS through student projects, please email cdsindustry@nyu.edu. For more color on the podcast and additional commentary, please subscribe to my newsletter at vasantdar.substack.com. Hello, and welcome to Brave New World. My guest today is Seth Shostak, who's a professor of astrophysics at the SETI Institute, which stands for the Search for Extraterrestrial Intelligence. I found my way to Seth through one of my previous podcast guests, the paleontologist Peter Ward, who studies life at timescales of millions and billions of years, and during our conversation mentioned the famous Drake equation, which serves as the basis for estimating the chances of intelligent extraterrestrial life in the cosmos. Seth has written a number of books on extraterrestrial life, including Life in the Universe, Sharing the Universe, and Confessions of an Alien Hunter. I find his work as one of the frontier scientists in physics absolutely fascinating. Seth, welcome to Brave New World. I am delighted to have you on the show.
Well, it's great to be on George Orwell's famous podcast,
Thank
Brave
you.
New World.
Thank you for that. Yeah, well, Aldous Huxley, actually, but I'll take Orwell too.
Close, but not right.
Yeah. So, Seth, I'm really looking forward to this conversation. Thanks for doing this. But let's start with a little bit about you and your path to this point. What got you into astrophysics and ultimately to the SETI Institute?
Well, it's a long story, but fortunately, it's extremely tedious. But I'll just tell you very briefly. I had studied physics as an undergraduate. I applied to graduate school in the physics department at Caltech. I was accepted, but then I thought I was really more interested in astronomy. So I asked, could I just transfer to the astronomy department there, Caltech? And they said, sure. So that's how that got started. Now, once I was in astronomy, I guess somewhat naturally gravitated to radio astronomy because radio happened to have been a hobby of mine, and I felt more familiar with the technology of radio astronomy. It was a good time to be in radio astronomy too, because it was still a field that hadn't been explored very much. So there were lots of interesting things to do.
Did you, by the way, know Arno Penzias?
I did not know him. I met him, but yeah, he was also at Princeton, but he was not on campus with the undergraduates very much, as far as I know. I never saw him there.
So what was radio astronomy all about in a nutshell?
Yeah, at that time, it was kind of a novel idea to look at the sky, not with a conventional mirror and lens optical telescope, but to use a telescope that could pick up radio waves. And sure enough, the universe was producing lots of radio waves. So almost every time you pointed a radio telescope, which was just a big antenna, every time you pointed that at the sky, you would find something new.
So, to frame this conversation, you, according to what I've read, are a big believer that, or rather, you think there's a high probability of extraterrestrial life out there. And you're actually pretty optimistic that we might find signs of it, in the next few decades. Tell us a little bit about why you think that's the case. What brought you to that view?
Well, I think it all comes down to what's called in science the principle of mediocrity. As a student, I figured that simply applied to the practitioners, but actually that's not what the deal is. The deal is simply that if you think you're special, you're probably wrong. And so, yes, we live on a planet with lots of life. There's life all over the place. It's hard to find any place on the planet where there isn't any life. Life seems to be some sort of infection of this part of the cosmos. And if you apply the principle of mediocrity, then you can say, well, if it's happened here, there are a trillion other planets in the Milky Way galaxy. surely it has happened in other places as well. So that's basically it. It isn't that we have any evidence that there's anything else alive out there, but if not, that would make us very special. That would make us a miracle in some sense. And believing in miracles is usually not something that scientists endorse.
So are you religious by any chance?
Not especially religious, no.
You a Pink Floyd fan?
No, I think that may be a musical group. I'm not sure. It may be that artist group that, makes graffiti in Newark, New Jersey. I'm not sure. But no, Pink Floyd is after my time. My musical tastes go back to people that have been dead so long that nobody even knows where they're buried.
Oh, come on. That couldn't possibly be the case. You're not that much older than I am. But, I only ask about Pink Floyd, obviously, because of their famous line, is there anybody out there? Which is the question you're asking. So tell us a little bit more about what SETI is all about and how that got set up and how you found your way there.
Yeah, well, SETI, which, of course, is just an acronym that stands for the Search for Extraterrestrial Intelligence, that's an idea that goes back quite a ways. It goes back like more than 60 years now. The idea that there might be life on other worlds in our cosmos, that is also a very old idea. You can find, science fiction stories about that going back to the earliest part of the 20th century. So again, the idea that aliens might exist is not a new one. The question of, well, can we get in touch? Can we prove that some way? People thought about that too. I mean, in particular, let's look on Mars. And as you know, around the 1890s, 1900, there were reports, mostly by this guy, Percival Lowell, a very clever astronomer in New England, that he could see canals crisscrossing the surface of Mars through his, I think it was an 8 or 9 inch telescope. Those canals were not there, lamentably, but the idea was firmly planted in the American consciousness that, in fact, not only was there likely to be life in space, but some of it could be fairly clever and relatively nearby, only 35 million miles away on Mars. It's an old idea.
When and why did this become sort of the realm of science as opposed to science fiction, right? You mentioned 60 years ago, and I think you're referring to that meeting of 1961 organized by Frank Drake, if I'm guessing correctly. Is that when we started taking the notion of extraterrestrial life seriously in science?
Well, I think that we probably always took it somewhat seriously. The question was, well, okay, it's a nice hypothesis, but what can you do with it, right? It's easy to say, I think there's lots of life out there, but that doesn't mean very much in science. Can you devise an experiment to prove that, or maybe to falsify it? And Mars was the obvious candidate to try and prove it, because Mars, at least as it was known, 100 years ago, seemed to be rather similar to Earth in terms of its conditions. It had a 24-hour day, rather coincidentally. It had seasons just like the Earth. It was a little smaller than Earth, but fundamentally, it wasn't all that different. It had an atmosphere. People at that time weren't quite sure what was in the atmosphere, and what is in the atmosphere is mostly carbon dioxide, not great to breathe. And it's a very thin atmosphere. It's about 100 times thinner than what we have here on Earth. But nonetheless, of all the planets we knew about, Mars was the obvious candidate to look for some life elsewhere. And people had no trouble finding it either, which was, encouraging, but somewhat misleading.
What do you mean, no trouble finding it? You mean?
Well, there were many claims of evidence showing that there was life on Mars. I mean, leave the canals aside for a moment. I mean, what Percival Lowell saw, the canals that he mapped so assiduously back in the beginning of the 20th century, those were all non-existent, optical illusions most likely. But he published it. He wrote 3 books on the subject, as I recall. So finding life nearby was, as I say, relatively easy. And in fact, when the first landers plopped down onto the Martian surface, that's a while ago now. That was in the 60s or 70s, somewhere there. Even Carl Sagan opined that he expected that, when they turned the cameras on this lander, they would see that, the surface of Mars had, bushes or maybe trees or maybe grass or something that life would be obvious just by turning on a camera on a lander. It was it was not at all radical to suggest that there was life on Mars. It turned out that there may be life on Mars. There may have been life on Mars, but it's not so easy to see. So we still don't know.
So we don't know whether there was ever life on Mars.
No, not in a conclusive way. I mean, it's not an unreasonable hypothesis, but it turns out that if you study the hydrological history of Mars, the presence of water on Mars, it was a better place a couple of billion years ago. There was more liquid water around. Mars has sort of gone bad, like many of my high school friends. So, it's possible that we missed the chance to see living Martians, but there may be remains of Martians. Probably not the kind that you see in the movies, but something that's alive.
This reminds me, like a long time ago, I saw this documentary featuring James Lovelock, who had this Gaia theory. And he said that you should be able to detect whether there's life on a planet just by looking at its atmosphere. And he said Mars's atmosphere suggested there wasn't life. Does that ring a bell?
Yeah. He was the advocate of the Gaia hypothesis, I believe, Lovelock.
Right.
Yeah, and it's true that if any aliens are studying the Earth with a big telescope, and they study the atmosphere of Earth, which is not so hard, you just use what's called a spectrograph. You just study the composition of Earth's atmosphere. You would find things in it like oxygen. We don't think about that much, but I don't know, something like 20% of Earth's atmosphere is oxygen. Most of the rest is carbon dioxide and other things. Carbon dioxide is not so interesting. Every planet in the solar system has a lot of carbon dioxide in its atmosphere, if it has an atmosphere. But Earth also has oxygen, and that's rather unusual. How do you, because oxygen tends to kind of disappear from an atmosphere. To begin with, it turns all the iron in the soil to rust. That uses up a lot of the oxygen. But we have oxygen in our atmosphere thanks to plants. And so if you find oxygen in the atmosphere of some other planet, that would be big news. And you would say, well, we're not sure, but there's reason to suspect that there's some sort of plant life on that world.
So, Seth, like just stepping back a little bit, from that time, I mean, I think that was like in the maybe 80s or 90s that I first came across that Gaia hypothesis. Like what have we learned in physics and astronomy, like in this century? Because when I was talking to Peter Ward, who's a famous paleontologist, on reading his book, I this is something I was completely unaware of about the kinds of things we've just learned in the last 20 years about life on Earth. That was really sort of interesting, and I suspect physics and astronomy has gone the same way, just with the kind of instrumentation and data that have become available in the last 20 years. How has that changed the state of the art in physics and astronomy and how we think about, life on Earth and life potentially in the universe?
Well, I mean, to the extent that you understand more physics, then you understand more about, what's going on here on Earth. I mean, that's fairly straightforward. That's certainly the case. We know a lot more about what's going on in the cosmos now than we did, well, even 20 years ago, although I would say probably it's better to push that back a little bit. But, we didn't know, we didn't even know about the Big Bang for a long time. And now, most astronomers accept that the present universe evolved from a Big Bang explosion, a theory that a lot of people objected to simply on the basis of not liking the idea, not even looking at the evidence. But there is evidence that there was such a thing as the Big Bang. These are all relatively new developments. And, the past couple of decades has seen these developments proliferate, mostly because of the developments, as you say, in the instrumentation. We have telescopes, radio telescopes, optical telescopes that allow us to look far away, which means to look back in time and learn something more about how the universe was long before we got here. This is, just like physics. We know a lot more physics today than we did before the Second World War, simply because the instruments have gotten better.
So what would you say are I guess, the 2 or 3 key discoveries or, for lack of a better word, theories that have come up in the last, I don't know, 20, 30 years that didn't exist that far back?
Well, I don't know about theories. I mean, there are new theories, of course, all the time. Physics, quantum mechanics is not something that many people talked about before 1900, for example. That's all completely new. But in terms of what we know about the universe, again, it's mostly an observational problem. Do we have instruments that can tell you what the atmosphere of Mars is like? And the answer is, well, we didn't have such instruments, even 100, 150 years ago, but we do now. And so we can look at planets and see, what's in their air, if you will. These are all instrumental changes, and they're fundamental because they tell us things that we had no way of knowing beforehand.
So let's come back to kind of the sort of, I guess, core question of this conversation, whether extraterrestrial life exists. How do you even begin to formulate an answer to that question, to take it from sort of the realm of science fiction to science? Like what's the thinking? How should one think about that?
Well, I think that you just said it. I mean, the question is very simple. Does extraterrestrial life exist? That's good enough, right? That's the question. That's the fundamental question. And in terms of, well, how are you going to answer that? Well, you can't prove that it doesn't exist. Of course, proving a negative is always a challenge, but you might prove that it does exist by finding it. It's very straightforward. And finding it may just involve sending, the right kind of lander, which is to say the right kind of spacecraft with the right kind of instruments to a planet like Mars and see if there is any life there. There could be, Mars could be covered in microbial life, for example, and that wouldn't be very obvious when you look at it from Earth with a telescope. So finding it is the way to answer your question. If you don't find it, unfortunately, that doesn't prove that there isn't any life out there. It just means you didn't find it.
But let's just go a little deeper into that, right? Because after all, we're interested in the existence not just of life, but of intelligent life in the universe. Like, so let's just take it a little further, because that's what you're interested in, and that's what you're looking for. How do you get your head around answering that question? Because as you say, I think it's sort of there's just because you haven't found it doesn't mean it doesn't exist. So how should you think about it, I guess, in maybe even probabilistic terms? What's the likelihood of it existing?
Well, nobody knows that. I mean, all you can say is that, well, it happened here. And is Earth so special that you won't find the conditions that you find here on Earth? You won't find them anywhere else in the cosmos. And the answer to that is, well, no. To begin with, planets, 50 years ago, planets were somewhat controversial in astronomy. Were planets a fairly rare occurrence, or were there planets everywhere? Just pick the next 100 stars you can find, and you're going to find a lot of planets. And it turns out that that's closer to the truth than to say that planets are rare, an hypothesis that had a long history, actually, for a while. Planets are very hard to find from a distance because they're small and they're dim. So you could hypothesize that there are planets around other stars. But only in the past few decades has it become possible to actually find such planets. And usually very indirectly. You don't see them directly in general. You just see the effects that they have on the motions of the star that's at the center of their solar systems. So these are all relatively new developments, mostly prompted by improvements in technology. But now we know that, the number of planets in the Milky Way galaxy, our galaxy, it's probably on the order of 1 trillion with a T. So, that's a lot of planets, and most of them are going to be somewhat uninteresting, like Neptune and so forth. I mean, not to cast any shade on Neptune, but, Neptune's not a place where you're going to find a lot of life. But there are also going to be planets in this trillion planets. Some of them are going to be okay. Some of them are going to be the kind of planet that if you threw all the biology of Earth onto that planet, a lot of it would survive. So it may be that life has sprung up in many, many worlds. That's kind of the default assumption here, that we're not all that special.
So Seth, when I was asking earlier about, what we've learned in the last 20 or 30 years that we didn't know before. I guess one of the things I had in mind was what you just said, which I guess physicists refer to as the wobble method, that's enabled us to find evidence of a lot more Earth-like planets. Whereas, my understanding is before that we'd focused on the large ones, and didn't, weren't really aware that there were that many Earth-like potential planets out there with a T, as you point out. Is that right?
Well, that's sort of right. I mean, it's true that it's much easier to find big planets than small planets because the way you find them is not by looking through a telescope and actually seeing them. That almost never happens. What you do is you see the effects that world might have on, for example, the star that it's orbiting, right? You think of the Earth going around the sun, okay, but in fact, in some sense, the sun goes around the Earth too. Not very much, but the sun actually wobbles a little bit. It moves back and forth if you were to look at it from far away because of the planets going around it. So that's a way to find those planets without actually seeing them. And those are the sorts of techniques that are used to find planets around other stars. We don't, in general, see them directly. We just look for the indirect evidence that they're there.
I guess I was trying to lead you towards the Drake equation, which seems to be one of the famous equations out there that people use to think of, I guess, the number of possible civilizations out there that may have developed that are similar to ours. Do I have that right?
That's fair enough. The Drake equation actually was cooked up by Frank Drake in 1960, I believe. And the idea was that it was to be an agenda for a small meeting he was having with about a dozen people to discuss the possibility of life, even intelligent life, elsewhere in the cosmos. And as an agenda for that meeting, he devised this simple equation, which, it's designed to give you an estimate of n, as in number. N is simply the number of planets that might be able to support life that you can find, for example, in our galaxy, that kind of thing. So the Drake equation is indeed simply a tool to kind of tell you, well, what's important if you're going to look for other worlds like the Earth.
So can you walk us through it, the main components of it? Because, you've written about it and you've written about the fact that some parts of it are maybe easier to estimate than others. So can you just walk us through it so we have a better sense of what this number might actually be? And, eventually Sorry, go ahead.
No, it's fairly straightforward. I mean, it is designed, as I say, to give you an estimate for n, the number of worlds like the Earth, the kind that can support life, or that even do support life, say, in the Milky Way galaxy, just in some sample of star systems. And obviously that depends on how many stars have planets, what fraction of those planets are somewhat like the Earth, in other words, that could support life, and then, various factors about, well, how many of them actually are out there. It's a hard question to answer because planets, again, are very, very difficult to find and study, right? Because they're small and they're dim. They're not like stars, which put out, an enormous amount of light, and that makes them relatively easy to find. Planets are very hard to find. And this is an old question now, but people have tried for a long time to make some estimate of how many worlds out there could support life or actually do support life. And, people are of various minds to this because you can't, if you will, answer this question by simply pointing telescopes at the sky. Our telescopes are still not good enough to give you a conclusive answer. It looks like planets are very, very commonplace, that most stars, 80% of them, have planets. And many of those planets aren't terribly interesting from the standpoint of life. But if you have a trillion planets in the Milky Way, which is maybe not a bad estimate, some of them are going to be okay. It's like buying a trillion lottery tickets. Sure, most of them are losers, but they're not all losers.
I really like the lottery ticket analogy, although I guess it assumes that there must be some winners. Okay, so that's sort of one part of the Drake equation, which is just what's the number of planets out there. What about the other parts, which is the fraction that might support life, the fraction on which civilizations might occur, I guess, and then the fraction that might still be around, right? I mean, considering, that maybe some civilizations just destroy themselves, and so they may have existed, but they may not be around, and that may even happen to us. So how do you think about those four parts?
Most of them are rather difficult to measure. I mean, in the end, you can sit around and have interesting dinner conversation about this.
But you just said that the number of planets is a trillion plus. So that's it's been hard to measure, but you've got a reasonable estimate, don't you? So
you can, but that's the easy part. That's the astronomy. But the next part of the question, which you've already alluded to, is, well, what fraction of those planets could support life? And in order to answer that, you have to sort of define, what do you mean by that? I mean, what kind of planet could support life? Could a planet like Jupiter support life? Well, that kind of thing. So once you've done that, then you can maybe make an estimate of what fraction of planets out there have the conditions that would allow life to begin, but also to continue, that it's a world that has life and continues to have life. And all we can do, I mean, obviously you could write things down. You could say, well, you need liquid water or some sort of liquid on the surface of the world in order to foment the kind of chemistry that life requires, and so forth and so on. You can do all these exercises. But in the end, you don't know, because this is something you have to actually observe. This is something you have to measure. Astronomy is pretty much an observational science. And as a consequence, if you're talking about something that you can't measure, that you can't observe with a telescope or some related equipment, then from astronomy's point of view, it's not necessarily a very interesting question.
Sure, but you still have to have reason to point your telescopes out there, right? I mean, clearly you think that there's reason to point telescopes out there because there's a reasonable probability of life, because if you plug in terms into the Drake equation, it gives you a number. Now, sure, there can be like a very wide variance in that number, but clearly there's something about that equation that gives you the confidence that there's a high probability that life might exist. Now, you said, okay, there's a trillion planets. The part, I guess, of the Drake equation that gives me pause is the probability of a civilization like ours developing that can then discover science, discover the laws of physics, find technology that sort of, implements those laws of physics, create telescopes. And I think what you said earlier is that there's nothing special about that. And I just find that a little hard to believe because, if this asteroid hadn't hit the Earth 65 billion years ago, maybe we wouldn't even be around. So isn't this like really kind of a very unusual thing? Like, what makes you believe that there's nothing special about what happened here on Earth?
Well, it's nothing more than a belief, which in science should have zero weight. Actually, it's only derived from the fact that if you think there's something very special about your circumstances, you're probably wrong. Right. Astronomy has certainly proven that over and over again. Right. The Earth, it wasn't so long ago, 4 or 5 centuries ago, when most scientists, to the extent that that term even existed, which it really didn't 5 centuries ago, they assumed that the Earth was the center of the cosmos. Most of them believe that. Right. But belief is not very valuable in science. And it turns out that, well, the Earth is not the center of the cosmos. That was a big revelation when Copernicus kind of showed that, well, actually, in our own solar system, the sun is the kingmaker. The Earth is just another, flittering little small piece of rock orbiting the sun. This has sort of been a leitmotif in our discoveries of the last half millennium, namely that the situation here of Earth orbiting a sun-like star is maybe not unusual. In fact, it seems not to be unusual. And as a consequence, this principle of mediocrity, which says that, look, your situation is probably not so special, something that, your parents kept trying to drill into you when you were a kid. I mean, it seems to be true. We're not all that special. Consequently, if you say, well, I think that there are probably aliens out there, that's hardly a radical statement.
Well, I don't know. I mean, I guess if I apply what you're saying to economics, that there's nothing special about you, I'm more willing to believe that, that people who, let's say, believe they have superior skills at, forecasting the economy or forecasting financial markets or something like that, I can believe that people might be deluded if they actually feel that they're special. On the other hand, like the existence, us, and I'm going back to my conversation with Peter Ward, who I guess holds a different view, right? I mean, his view is that actually life has existed for a long time, probably soon after the formation of the Earth, and once life establishes itself, it's very difficult to get rid of it, right? But he points to 10 extinctions that have occurred on Earth. And after each extinction, life sort of flourished. But it was different, right? Each time the life forms that flourished were different. And after the last one, we've sort of come, mammals have assumed primacy and all of the other stuff, good stuff that's followed. Isn't that different from sort of what you're saying? And, what's wrong with that theory? That actually there is something so special and so unusual that it's very unlikely that a similar set of events would have happened elsewhere. It's not obvious that that should have been the case because what's happened on Earth seems to have been such a complete set of flukes, in a sense.
Well, keep in mind, Peter Ward wrote a book, about 20 years ago now, a little more, actually, with Don Brownlee, who was also at the University of Washington, called Rare Earth, in which they argued that, contrary to what most astronomers would tell you, the Earth, the existence of the Earth, the conditions of the Earth, and the history of the Earth, which is to have fomented life and then eventually fomented intelligent life, produced intelligent life, that could be very, very unusual. That could be special. We could be some sort of miracle. And the problem is that there's only one data point, the Earth. We don't know of any other world where there's life. That's why it would be so revolutionary to find bacteria on Mars, for example, Martians. If you were to find that, then you would say, well, the assumption that Earth is so special that it's, you shouldn't expect to find life elsewhere, that's completely wrong, right? But we haven't done that yet. I suspect that it will happen, but that's just my guess, and a guess doesn't count for much here. But keep in mind that Peter Ward and Don Brownlee were of the opinion that Earth was special, and their book consisted essentially of a laundry list of ways in which the Earth was different from, your average planet, and consequently, Earth was rare, and life could be rare, and intelligent life could be even more rare, if you will, rarer.
Yeah, and that's what I'm pointing to, I guess, the intelligent life part, right? I mean, I agree. I mean, if we actually find the evidence of life anywhere, like microbes, that would be incredible, right? That probably one of the most incredible scientific discoveries. But even going from that to intelligent life doesn't seem sort of obvious to me. I mean, at least when I read Peter's work and his sort of, really sort of painstaking analysis of all the fossil remains and all of that to show that life has been very, I'm trying to find the right word, but special, unique, unusual.
Improbable, maybe.
Improbable, yeah.
Yeah, well.
That intelligent life has been so improbable.
Well, until we have a second example, you can hold that view. I don't share that view. Most scientists I know don't share that view. But as I say, Don Brownlee and Peter Ward wrote a book about this, and it caused quite a controversy. I think it was 1996 when that book came out. I'm not entirely sure of that. But because it was against, it sort of flew in the face of the principle of mediocrity, which I've already mentioned, sort of governs most scientists' thinking on this subject, because they've been burned, scientists have, in the past by thinking that there was something very special going on here, right? Earth was the center of the universe, remember, for 1,000 years more, right? And it turned out that wasn't true. And that was really a slap in the face that, doggone it, if you think that you're special, chances are I'm going to bet against you. You're probably wrong. And maybe what Ward and Brownlee were saying is we may have gone too far in the other direction. Maybe it really is special. But all of this could be, could be answered, could be dealt with by lunchtime tomorrow if somebody were to find evidence for some sort of life on another world, right? I mean, if we found oxygen in the atmosphere of a planet around another star, that would be very significant. For most people, going to their jobs in the morning, walking around, and you tell them, there's evidence that there may be bacteria on this planet that's 50 light years away or something. They would probably shrug their shoulders and say, yeah, I knew that. Well, they didn't know it, but they certainly believed it. And it may be that that's the case, but we still don't know. We don't have more than a sample of one in this question. We only have the Earth as a harbinger or a habitat for life. And until we have at least one other, you can maintain a position in which you say, this is really special.
Okay, fair enough, Seth. So I think I've read somewhere that you actually believe that there's a reasonable chance that we might actually find something in the next few decades.
Yes. I'm happy to bet anybody a cup of coffee.
So what makes you optimistic, right? Because it's got to be more than just a belief, right? You must be basing that on data. I'm assuming.
I'm basing it on the level of technology that we have to find life. It's become easier to find life, right?
Yeah. So I guess I'm calling that data because I guess our ability to actually find life depends on our ability or our capacity for detecting it, right? So let's talk about that, right? Because it may exist, but if you don't have the capacity to detect it, we won't find it. So how do you sort of quantify our capacity to detect it? How do you think about that?
Well, I mean, I don't know. Everybody thinks about it differently, but I suspect that at the basis of all that is simply the fact that if you were to, in fact, try and find life on Earth from another solar system, suppose you're an alien, you're looking for life around, how would you go about looking for life on Earth? Well, one obvious thing is you might notice, gosh, a fair fraction of the atmosphere of Earth is oxygen. And that doesn't make any sense unless you have photosynthesis or something like it, right? Most of the oxygen in our atmosphere is due to plants. If you got rid of all the plants, that oxygen would get used up in rather ordinary chemical processes, turning all the iron in the ground to rust. That'll use up a lot of oxygen. And in fact, it did use up a lot of oxygen in Earth's history, but the plants replaced that. Right, they plenish the oxygen supply in Earth's atmosphere. So if you were to find another planet, here's planet X, and by the way, 20% of the atmosphere is oxygen. You'd say, well, I don't know what that means, Bob, but 20% is a pretty high percentage. It suggests that there's some process producing oxygen on that world, and yeah, it may just be chemistry, but on the other hand, it may be biology.
Yeah, okay. So, but let's get back to I guess what I was trying to get at it is what's our capacity to actually find these things, because at the end of the day, you're pointing something out there,
telescopes,
and, right? Yeah, so you're pointing telescopes out there, and clearly you can't point them in every possible direction. So there must be, you must have some sort of an estimate about the likelihood of finding life given your capacity to find it.
Well, it's not so clear that that actually gives you an estimate. All you can do is say you could find oxygen in a world this far away at this level, right? You could sort of quantify how good your instruments are, but they might not be good enough to find the aliens. We haven't found the aliens so far, and yet, if you were to ask most astronomers, do you think there are aliens? I think most of them would say, yeah, probably there are, right? So the fact that you haven't found them is just, all that is making a statement about the level of your instrumentation, the kind of things you can do. And that's why it's very tempting to look for things that actually are not very hard to produce, like radio signals coming from some alien world. Those are fairly straightforward to produce, and they're somewhat easier to detect than a lot of things. So, that's something that the whole SETI project tries to do. We just try and find radio signals that are produced by a transmitter coming from some other star system. And that would answer this whole question overnight, right? And suddenly, well, this is not nature. This is something that's been engineered.
But that's what I'm getting at. Like, isn't that really hard to detect? Like, given that signals kind of dissipate, with, proportional to the square root of distance, so even if someone were transmitting something like that,
fortunately, it's the square of the distance, but it's yeah. Well, I'm not quite sure what you're trying to say. We have the ability to detect at some level indications that there's, technology on another world. We haven't found it yet. What does that mean? Does that mean that there are no aliens with technology out there? Or does that mean that our instrumentation is still not sensitive enough? And I think, based on sort of historic precedent on it, and I guess most history is a precedent in some sense, it could be that there's plenty of life out there. There's plenty of intelligent life out there. That's still a possibility. We haven't detected it so far, but that's simply a reflection on the state of our technology to find it.
Is your estimate, let's say that, that we'll find evidence of life in the next few decades based on sort of the rate at which technology is advancing and our capacity to actually detect it if it exists?
Well, of course. I mean, that's certainly one component, and that's maybe the most important component. If your ability to find evidence of intelligence elsewhere keeps getting better, then, from my point of view, then the chances that you'll find it also are getting better, unless you're of the opinion that, well, no, humans are the smartest things in the cosmos. A lot of my friends seem to believe that, but I don't think it's true.
So, what are the other, I guess, the big questions in astronomy?
The big questions in astronomy? Well, I don't know that the questions have changed very much, even in the last 100 years. Our ability to come up with answers has certainly changed. But the big questions in astronomy have always been, where did the universe come from, right? Why are we here? Where is it going? What's going to be the end of the universe? Is the universe going to have an end, or is it just going to slowly fizzle out, right? These are the big questions in astronomy. One of the questions, which is partly astronomy and partly biology as well, is there any other life out there? And is there any other intelligent life out there? But that's, from the astronomer's point of view, not necessarily the big questions for astronomy. The big questions for astronomy have to do with, bigger picture things like, how did the universe begin? Where did it come from? Are there other universes?
What about this question about how long we have on Earth, right? Because again, reading Peter's book, he talks about sort of this zone of habitability and that, the sun's 30% hotter than it was, when Earth came to existence, and eventually it's going to get too hot, like that the planet of the water on Earth will evaporate and it'll become uninhabitable. Is that a view that you share?
Well, that's not so much a view. That is simply an interpretation of what we know about what's called stellar evolution. How do stars change as they get older? Humans change as they get older. So do stars. Somewhat counterintuitively, most stars get brighter as they get older, right? Very few humans seem to share that path. But, that allows you to say that, okay, in a couple of billion years, the sun will be so bright that it'll evaporate all the oceans, and that'll be it for life on Earth. Okay, that's just astronomy. And, that's probably true. But saying that it's true, what's your next question? I mean,
well, no, but when you say it's probably true, I mean, do you mean, well, it's either true or it isn't, right? I mean, if the sun's getting hotter and brighter, and if it continues to go that way, then isn't it the case that Earth should become uninhabitable?
Well, not necessarily. I mean, yes, if you just leave everything the way it is and just sit back and watch, that's probably what it means. But on the other hand, if there are intelligent inhabitants on Earth, unlike, for example, the trees outside my window here, the intelligent inhabitants of Earth could change the narrative, right? If you know that the sun is going to be slowly getting brighter and it's going to boil away all the oceans, that's not good for the economy down at the beach. So you probably want to do something about it. And you could do something about it, at least in principle. It doesn't violate physics, to conceive of a project where you build a giant sunshade to block a lot of the sunlight hitting the Earth and just put it in orbit. I mean, okay, we're not doing that now, but you could do it. And it's not even all that hard, right? It just requires that you decide that you're really going to do it. Or you just, I mean, if you could arrange to put rockets on one side of the Earth and blast us away from the sun a little bit so we get farther away out, maybe toward the orbit of Mars, things will cool off, and maybe we have a long future history to witness. So, yes, these are interesting questions because obviously they affect what happens to Homo sapiens in the future, but they're not things that are going to happen overnight. There's plenty of time to think about what to do about this stuff.
Indeed. Although it seems like delaying sort of the inevitable, right? It seems sort of inevitable that the zone of habitability would disappear.
Well, that may be inevitable, but that doesn't mean you have to deal with it this week.
Fair enough. Yeah, it's a good thing that's not a pressing problem. So, Seth, I want to sort of tie this back to a previous conversation I had with a neuroscientist, about whether free will exists or whether life is deterministic. Do you have a view? I mean, when I was reading your materials and thinking about our conversation, I wondered whether you would fall in the determinist camp or whether you actually believe that we have free will.
Well, that's more philosophy, which is hardly my strong point. I'm not quite sure what my strong points might be, actually. But yeah, do we have free will? I like to think so. Otherwise, I wouldn't really be able to answer the question. I think that we get to choose our future in many ways and to shape it. And, that's not a bad thing. I mean, Earth has a lot of biota. There are a lot of living things out there. And most of it isn't capable of doing anything about long-term changes to the planet that might threaten their existence. Humans are different in that regard. We can do things. And I suspect that when push comes to shove, which it inevitably does with these kinds of existential threats, that we'll do something, right? At least some of us will do something.
A couple of questions, Seth, before we wrap up. So you've got these telescopes, pointing in the skies. And these days, Elon Musk is sending a satellite into space every week. So it's, our exterior is sort of blanketed with these satellites. Is that like causing any kind of interference or problems with your measurements? Or is that just insignificant?
No, that doesn't affect things. I mean, it's like saying, okay, there are thousands, 5 to 10,000 spacecraft out there, most of which are not functioning, but some of which are. And are they blocking the view of astronomers? Or can astronomers not do their jobs because of all this, if you will, space junk out there? And the answer to that is no, any more than, airplanes have blocked our view of the cosmos. Yeah, they can get in the way, and occasionally they do, but it's not a major problem. And so, Elon Musk, as far as I'm concerned, can put as much hardware out there in orbit as he likes.
Okay, good to know. Yeah, I just read somewhere that physicists were complaining that there's interference, but I guess what you're saying is that the density is just, not significant.
Yeah, interference is a different thing, of course. You could have one satellite with a very powerful transmitter on it that could interfere with a lot of stuff you're trying to learn from other satellites that are either in orbit or just shooting through space. So there's a potential problem there. There's also a limit to how bad the problem can get. There's something called the Kessler syndrome, named after a NASA scientist, Kessler, I forget his first name. But in any case, he pointed out that the number of satellites orbiting the Earth that we put there keeps growing. And at some point, you reach a density of these things that's high enough that they begin to collide with one another. So if two of these, pieces of space hardware collide, and then the result is a lot of fragments, if you will, which means that there are more collisions. And more collisions means that the chances of yet another collision go up, and you get yet more collisions. Pretty soon there's kind of a meltdown, and all of nearby space is filled with hunks of metal and pieces of satellite debris, and that make it very hard to put new stuff into orbit. This is known as the Kessler syndrome. And I don't recommend it because we don't have too many antibiotics against it. But, there may be a limit to how much stuff we can put in near Earth orbit. But look, space is big. You can put most of these things farther out and it won't affect their utility.
I'm trying to sort of put myself in your shoes, like in terms of like, what do you do every day? Like, do you wake up thinking, hey, this may be the day that we actually hear something from out there? Like, how do you?
No, I don't do that. I wake up every day trying to figure out, well, what meetings do I have to go to before lunch? Yeah, I mean, it's true that seen from the historical perspective, if we were to look at what's happening here in the beginning of the 21st century, from say 1,000 years in the future, what would be important, right? I mean, would it be the various wars that are taking place on the Earth? Would it be biotechnology? What would be the big things? And it's easy to speculate, and maybe some things are fairly obvious, but in general, we don't really see the big picture very well until we've lived it. I think that my answer to the question of what's going on now that will be transformative is probably the fact that we might find evidence that there's biology elsewhere. We haven't so far, but that might happen. It might happen in this century or maybe even in the next couple of decades. And that would be an inflection point for history, because you could say, look, there was history before we found out that there was life all over the place, and there was history after we found that out. And they would be different, just in the same way that, once the Europeans had managed to cross the Atlantic, history kind of changed. I think that we may be in for an inflection point similar to that.
I'm thinking of my, my childhood and college, when I was trying to figure out what to do with my life, and physics seemed I was drawn to physics, and then I went into engineering instead because my parents said, do something that will find you a job and make yourself useful. But I was really tempted, and the question I have for you is this like a real are we seeing sort of a golden era in physics and astronomy now? I'm thinking if I were to make that same decision now, how exciting is it?
Well, I think it is a golden age, if you will, for these disciplines, simply because the number of people that are working on problems in physics and astronomy, and for that matter, astrobiology, the number is far higher than it's ever been in the past. I'm sure that at least half of all the astrobiologists that have ever lived are alive today. Right? It's a discipline which has attracted a lot of people, largely because of the ability to find things that we couldn't have found even 50 years ago, simply because we didn't have the instruments that would allow you to do that. And, finding life elsewhere, that's sort of a discovery that you make once, right? After you found it, well, you can say, okay, oh, by the way, this planet also has life. Okay, that doesn't maybe make the front page anymore. So we're in an interesting period of time in which we have the ability to find life on other worlds. We haven't yet done it, but if it's there, I suspect we will find it, and we'll find it within the lifetime of the people who are watching these proceedings.
Yeah, no, that's pretty phenomenal. I mean, I can't imagine too many questions that are more interesting than does life exist out there? So is physics something you sort of encourage people to, young people to get into as a career if they're so inclined?
Well, what I would say to young people as advice for their career path, the only advice I would give them is study something that you find interesting. If you don't find it interesting, you're not going to get very far with it. So if you're interested in, the behavior of atomic particles or subatomic particles or whatever, study physics. If you're interested in whether there's life out there, then you study astronomy, biology, whatever. I mean, this is a good time to do that because we have the kind of instruments that could actually answer a lot of the important questions.
Yeah, that's certainly true. And what you just said, I guess, is really important, that, we have the kinds of instruments that can answer these kinds of questions, because it's one thing to have the interest in something, but it's another thing entirely to ask yourself, well, what's the state of the art of that discipline, and what's the likelihood of doing something really significant. And it seems to me that, just given the advances in science and technology, we seem to be at the point now where where we're able to observe things like never before. So,
yeah, no, I think that's fair. It's like studying chemistry, right? If you were interested in chemistry a couple of centuries ago, you might become an alchemist. And alchemists, their number one project was always trying to turn some base metal like lead into something valuable like gold, right? But they didn't know much about atoms and how atoms behave. And if they did, they would realize, one, what they're trying to do is extremely difficult, requiring technologies they didn't have. And maybe that would have discouraged them. We learned something from the alchemists, but it was only with the development of the theory of, atomic structure, where we finally understood chemistry, that you could make much faster progress. And we may be in a similar situation today.
Good stuff, Seth. I must say I am envious at just at the question that you're asking. It's such a big and important question. So I wish you success. I think it'll be pretty phenomenal if we actually do find existence of life, out there within our lifetime. That would be pretty phenomenal.
No, that'd give you something to talk about at dinner.
Indeed. Seth, thanks again so much for the conversation. Really enjoyed it, and I, enjoyed reading your writings. It's always fun to catch up on a discipline after all these years, and I just got a lot out of it. Thanks for that. Thanks for coming on the show. Really appreciate it.
My pleasure, indeed.